In this problem, we are supposed to use the thin lens equation to solve for the image distance, the image height, and the magnification of a flower. The problem reads, what is the position of the image of a 7.6 centimeter high flower placed 25 centimeters from a 5 centimeter focal length lens? What is the magnification of the image, and what is the height of the image? So we're going to separate things. What do we know about the object? What do we know about the image? And what do we know about the lens itself? And so first it says that 7.6 centimeter high flower, so the object itself, the flower, is going to have a height of 7.6 centimeters. And it says that the flower is placed a distance of 25 centimeters from the focal length. The focal length is 5 centimeters. We need to find out what is the magnification, the image distance, and the height of the image as well. Okay, so we're going to solve for this mathematically, but it might be a nice idea to actually see what it should be through a graphical method. This way we can check our answers. So let's actually see what it would be graphically. So we're going to draw, here's our lens, our principal axis. We have 1, 2, 3, 4, 5. This is our focal length. And there's a focal length on the other side as well. 1, 2, 3, 4, 5. Here's our focal length on the other side. The object is 25 centimeters. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So we'll draw an arrow. Here's our object at this location. We'll just continue a few lines over here as well. So our first ray would go parallel to the principal axis and then go through the focal point. So that's our first ray. Our second ray is going to go through the focal point on the left-hand side and then go parallel to the axis. So that is our second ray. And then our third ray is going to go through the center of the lens itself. That's our third ray. And so we see that they all intersect, roughly around 6.5. And we see that the image is upside down, so we expect our height to be negative. We expect our image distance to be positive because it's on the right-hand side. And we expect the magnification to be negative because it's upside down from the object itself. So this gives us an idea of what we should find. So let's first find, it says the image distance. That's our first step. What is the image distance? And we'll do so using the thin lens equation, which says 1 over the focal length is equal to 1 over the object distance plus 1 over the image distance. Now, as long as everything is in the same units, we're okay. So everything is consistently in centimeters, so there's no reason to change. We just have to make sure all the units are consistent. We do not have to be in meters per se. So we have 1 over the focal length, which is 5 centimeters, is positive because it's a converging lens. And that is equal to 1 over the object distance, which is 25 centimeters, is positive because the object is on the left-hand side of the lens. And we're finding the image distance in this problem. So we subtract 1 over 25 to the other side. And that gives us 4 over 25. But 4 over 25 is equal to the 1 over the image distance. So let me actually write that out. So we do have to flip this, and so the image distance is 25 over 4, which is 6.25 centimeters. It is positive because it's on the right-hand side of the lens. And so we see over here, we got 6.5. We were pretty close. And it is on the right-hand side of the lens, so it should be a positive number. Makes sense. Now we need to find the magnification. And so the magnification is the opposite of the ratio of the image distance to the object distance. So magnification is the opposite of 6.25 centimeters, our answer from the first part, over 25 centimeters. And so the magnification is negative 0.25. There are no units because the centimeters cancels out. It is negative because it's upside down. And we see that this one is upside down. And it's 0.25, which means that the image is a quarter, 0.25 times the height of the object. And so we see that our image is smaller than the object. And so that makes sense that we should get a number less than 1. Now for the last part, we're actually asked to find that image height. And so we'll again go to our magnification equation, but we'll use the other one, image height over object height. Magnification is negative 0.25. We're finding the image height, and the object height is 7.6 centimeters. So we multiply by 7.6 centimeters, and we get our image height to be negative 1.9 centimeters in length. So again, the negative means it's upside down. So if we go to our diagram, we see that it is upside down. And it is smaller than the object height as well. So again, it's a good thing to actually do the ray tracing method, to go through that process, just to see if your answers make sense. To get something completely different, you know that there was a mistake made somewhere. But we have our thin lens equation, and then our two equations for magnification. Just make sure that you're consistent with your units.